Let's talk about line graphs. So today's lesson is the last graphing lesson, and then you have two geometry lessons, and then that's it for the end of the school year, which is crazy. But line graphs fall into the same category as the other graphs that we've talked about, and there are just a couple vocabulary words that I want you to know about, and then we're going to get started on it. All right, so a line graph is a graph that uses line segments to show how data changes over time. The series of numbers placed at a fixed distance that label the graph are the graph's scale. The interval, or the difference between one number and the next on the scale, should be equal. So let's talk about those. This is a picture of a line graph. Let me get some color here. That is a line graph. And you can tell that it's a line graph because the dots are all connected by you probably guessed it, a line. Now, it's really the other two words that I want you to understand. So, a scale. The scale is going to be the distance between the axis and the top up here. So, this distance here. Now, for this particular graph, whoops, I didn't click the eraser, sorry. For this particular graph, it starts at 0, 0, and it goes up to 130, 130, okay? So the scale is 0 to 130. And try not to overthink that. It's seriously from the axis, which is almost always 0, to the highest point on the graph, and for this graph it's 130. Now our line doesn't go up to 130, but our chart does, so if there were more data we could go up to 130. Now we're talking about centimeters here, so I'll just put cm for centimeters, and then the intervals are the differences between the numbers. So how are they counting from number to number to number? And for here, they're going 10, 20, 30, 40, 50, 60, 70, and so on. How are they going? Well, they're counting by 10. So it's intervals of 10. And that's sloppy. I apologize for that. Let me be a better teacher. Okay, intervals of 10. Okay, and seriously, that's what it's counting by. So the scale is from 0 to whatever, and the interval is how much between. Now the most common ones are going to be tens. It's going to be ones. Some of them go by ones. The intervals on the x-axis are by ones. It's going to be ones. Twos are very common, and fives are very common. You don't really see like counting by sevens. Sometimes you do see counting by 20s. That's if you need a chart that gets really high really fast. So that's what those two are: scale, and intervals. Okay. All right. So let's look here at the very first problem. I have it broken up into a couple of slides, so bear with me if I have to bounce back and forth. And I'm going to use black for this one. Okay, a line graph, again, is a graph that uses line segments to show how data changes over time. The series of numbers placed at the fixed distances that label the graph are the graph's scale. The intervals, or difference between one number and the next on the scale, should be equal. So it says graph the data. Use the graph to determine the times between which the greatest temperature change occurred. All right, so what we're going to do is we have an interesting setup for this one because it has time on it, right? Still not a problem. So they gave us 1 o'clock and 51 degrees. So then we'll put in 2 o'clock. And at 2 o'clock, it was 49 degrees. 49. At 3 o'clock, it was 47 degrees. At 4 o'clock, it was 44 degrees. At 5 o'clock, it was 45 degrees. And at 6 o'clock, it is 44 degrees. That's a bad 4, my apologies. And so is that one. And at 7 o'clock, it was 46 degrees. Okay, so we've got all those in. On the next page, I'm going to have to bounce back and forth, but on the next page, we're going to chart this, right? Okay, so it says step 1. For the vertical axis, choose a scale and an interval that are appropriate for the data. You can show a break in the scale between 0 and 40 since there are no temperatures between 0 and 40. Step 2, for the horizontal axis, write the times of the day, write a title for the graph and name each axis, then graph the ordered pairs. Complete the graph by connecting the points with line segments. So they titled it for us. They titled it Recorded Temperatures. They have the temperature on the y-axis, and they have the time on the x-axis. So it looks like they did 1 o'clock, 2 o'clock, and 3 o'clock for us. So let's go to 4 o'clock. At 4 o'clock, it was 44 degrees, and so that's on a spot right there. Now let me do this. Let me actually switch this to that same color, similar color, blue. Okay, so, oops. At 4 o'clock, it was 44 degrees. Okay. And I'm going to connect all of my lines at the end. At 5 o'clock, it was 45 degrees, so just slightly higher than this. That's pretty good. Now you can see over on the temperature side, it counts by twos. And there's a break from 0 to 40 because there just wasn't that, there weren't any low temperatures like that. So I actually don't like that one. Let me redo it. I'm going to try to get it right in the middle. That's a little bit better. So at 5 o'clock, it was 45 degrees. At 6 o'clock, it was 44 again. So I'll put that here. And at 7 o'clock, it was 46. So 7 o'clock was 46. That goes here. Now I'm going to try to do my best to line them all up. And not bad considering it's on the computer. All right, so now look at each line segment in the graph. Find the line segment that shows the greatest change in temperature between two consecutive points. So if we look here, what was the greatest change in temperature? Well, from 1 o'clock to 2 o'clock, it was only 2 degrees. From 2 o'clock to 3 o'clock, it was 2 degrees. From 3 o'clock to 4 o'clock, it looks like it was 3 degrees, and then it was 1 degree, 1 degree, 1 degree. So the greatest temperature difference happened between 3 a.m. and 4 a.m. Okay, do you see that? Do you see how this has the biggest space right here? It climbs, or I guess it declines the most. It started at 3 o'clock, it was 45 degrees. And at 4 o'clock, it was 47 degrees. And at 4 o'clock, it was 44 degrees. So that's a difference of 3 degrees. Everything else was either 2 degrees or 1 degree. Okay, let's carry on. Jill used the rain gauge to collect data on the total rainfall during 6 days at her home in Miami. She read the amount of rain collected in the rain gauge each day and did not pour it out. Her data is shown in the table. Make a line graph to display Jill's data. So on Monday, there were 2 inches of rainfall. Let me switch to black again. On the next day, which would be Tuesday, I'll just do TUE for Tuesday. On Tuesday, there were also 2 inches, so we can gather that there probably wasn't any rain. On Wednesday, WED, on Wednesday, there was 3 inches in the gauge. On Thursday, I'll do TH, oh boy. Some of you guys are so good at writing on here. THU. On Thursday, there were 6 inches in the rain gauge. On Friday, there were 8. And on Saturday, there were 9. Okay, so now you'll notice on here for the x-axis, we're not going to have numbers, we're actually going to have abbreviations for the words Monday, Tuesday, Wednesday, Thursday, Friday, and Saturday. So step 2 says choose a scale and an interval for the data. So we have to look at our numbers. We have 2, 2, 3, 6, 8, 9. Depending on how big our chart is, we could either count by twos or we could count by ones if we have 10 lines. So let's go see what we have. Step 3 says label the horizontal and vertical axes, write a title for the graph the ordered pairs, connect the points to the segments. Okay, so we're going to bounce back and forth again. Here we go. So if you look at this, we actually have quite a bit. I'm going to very carefully, oh my gosh, that looks so good. Wow, I'm super impressed with myself for that. And that one's okay. So I can see on here that we do actually have enough numbers, but they're really close together. So instead of trying to cram them all in, I'm going to count by twos like they did before, and I'll just skip lines. So this would be 0. That would be 1, 2, 3, 4, 5, 6, 7, 8, 9. Whoops. 2, 4, 6, 8, and 10 would go right there, not 9. 10. Okay, so that's quite nice because it gives me a little bit more space to work. It doesn't look sloppy. Now, on the bottom, I need to go back and oh, the chart's still right there. On the bottom, I need to write the days. So again, I'm going to skip lines just so it doesn't get sticky, like sloppy, I guess. But you want to make sure that you're always on a line. You don't want to be in the middle of lines. So I'm going to go with this first one here as Monday. This will be Tuesday. This will be Wednesday. That'll be Thursday, Friday, and Saturday. Now I'm going to plot these in red. Hopefully red will show up the best. So on Monday, there were 2 inches of rainfall. So on M, I'll go up to 2. On Tuesday, there were also 2 inches of rainfall. So I'll go over to T, the first T for Tuesday, and go up to 2. For Wednesday, there were 3. Now I don't have a 3 on there, but use your common sense. It would go right in between 2 and 4. On Thursday, the second T, there were 6, so that would go up to here. On Friday, there were 8, so we'll go all the way up to 8 on the F. And Saturday, there were 9, so use your common sense again and go in between 8 and 10. Now, I'm going to very, very carefully try to connect all of these. So, good. Not bad. Not bad. Good enough for the computer. Now, if you were using paper and pencil, you could use a straight edge and definitely make it a lot straighter, a lot nicer. But this gives us a decent visual. So if I go back here, it wants us to label. We need to label the horizontal and vertical axes. Write a title for the graph. So 3 things we need to do. We need to first title the bottom. This is obviously days of the week. Okay, and then on the other side, it would be, so we have days here. What would the other side be? It would be rainfall. And you always want to make sure you put your units, and this is in inches. So I'll put IN for inches. And then the title is going to be, we could title it rainfall collected, like the table says. You could say rainfall within a week. You could say anything that relates to the rainfall, basically. You could say, what was her name? Her name was Jill. Jill's rainfall data. Any of that would be fine. So I'm just going to put rainfall collected. Now, it's important to make sure that you have the x-axis and the y-axis labeled, that they have a title, and that you have an overall title for your chart so that people know exactly what they're looking at when they look at it. Otherwise, it won't make any sense. So here are two questions based on the chart. So I'm going to bounce back and forth between them. On which day was the total rainfall recorded the greatest? So looking here, which one was the greatest? Hopefully you would say Saturday. Saturday had 9 inches. Oh, no, I'm glad I caught that, and I'm actually glad I made a mistake for you. You have to be very, very careful because you have to listen to pay attention to the wording for it, right? So let's go back and look at that one more time. On which day was the total rainfall recorded the greatest? So you have to ask yourself, is there any adding that I need to do there? And the answer is no. So you're just going to look for the highest number. So back here, again, back on Saturday, it was 9 inches. So we'll go here and we'll go Saturday. And then number 2, on which day did Jill record the greatest increase in rainfall collected from the previous day? This is where you have to do your math, okay? So we're going to go from Monday to Tuesday was 0. It was 2 to 2. 2 minus 2 is 0. So here is 0. From Tuesday to Wednesday, 3 minus 2 is 1. From Wednesday to Thursday, 6 minus 3 is 3. From Thursday to Friday was 8 minus 6 is 2. And from Friday to Saturday, 9 minus 8 is 1. So the greatest was here on Thursday. That was the greatest increase. So our answer would be Thursday. Okay, just make sure you're reading the questions through and you're really looking at the charts. You might have to bounce back and forth, and I do apologize for that. These screens are kind of small. There's not a lot I can fit on them, but I trust that you'll use your best judgment. All right, let's look at these last 3. I know the next number wasn't 12. It went from 1, 2 to 12, but I really liked this true and false one, so I wanted to go over this with you. So if you look at the accumulated snowfall chart on the right there, we're going to be using that to answer questions 12A, B, and C. Okay, so the line graph shows the amount of snowfall, amount of snowfall over several days. For 12A through 12C, select true or false for each statement. And I'm going to use yellow because I think it'll show up pretty well. A, there was no change in the amount of snow from day 2 to day 3. Well, day 2 had 3 inches and day 3 had 4 inches. Those are not the same, so the answer is false. Okay, let me get my eraser, get rid of this, just in case I need to draw on there again. 12B, the greatest increase in the amount of snow between consecutive days, that just means in order, occurred from day 4 to day 5. Well, let's look. On day 1, let me switch to black. On day 1, there was 1 inch. On day 2, there were 3 inches. On day 3, if I could write a 3, on day 3, there were 4 inches. On day 4, there were also 4 inches. On day 5, there were, 7 inches. And on day 6, even more, there were 8 inches. So now we have to find the biggest difference, the greatest increase. They're saying from day 4 to day 5. So let's circle that and see if that's correct. Day 4 to day 5. So 4 inches to 7 inches would be what? It would be 3 gained inches. So from day 4 to day 5, 3 more inches of snow fell. Are there any days that have more than 3 inches of snowfall? The answer is no. So, excuse me, the greatest amount of snowfall was between day 4 and day 5. All right, number 12C. From day 1 to day 6, the amount of snow increased from 1 foot. Oh my gosh, this is all in feet. I totally couldn't see that. It's so small. Feet, not inches. From day 1 to day 6, the amount of snow increased from 1 foot to 8 feet. So it went from 1 foot to 8 feet. That's true. We went from 1 here to 8 here, or 1 here to 8 here. So yes, it's true. All right, I only did this kind of work for you for your work today. I think you only have 8 or 9 problems, so I think you'll be fine. Again, if you need help, don't hesitate to contact me during my office hours from 11 o'clock until 1 o'clock every day I'm here. All right, good luck.